Now, a little appreciated fact about phono equalisation, even amongst collectors, is that you need to equalise both the amplitude and the phase. Now, reciprocity is a byword of recording characteristic and replay equalisation. And essentially, if that characteristic is what's recorded, so let's say here there's cut bass and boosted treble, then what you need on replay is a complementary characteristic, and that's well understood. But in fact you need reciprocity in both in frequency and phase. And importantly, the correction curves in Stereolab are not derived from FFT curve filtering. Such a technique results in generation of non-causal linear phase filters, which do not correctly compensate for the phase distortion introduced in the preemphasis filter. Unfortunately, this is the technique employed in most of the software solutions commercially available. Not only does this technique result in frequency response anomalies, we've measured around 1 dB errors, but much more seriously it destroys the linear phase response of the preemphasis-deemphasis chain. So this is what happens when a sin x over x pulse has been encoded by a standard RAAA stage and then decoded in a perfect analog filter. So that's the sin x over x test signal. That's what it looks like once it's been encoded in the RAAA encoder. And if it's decoded with a proper analog circuit, it comes out looking the way that it went in. So not only have the frequency components been recovered, but their phase is recovered too. And that's exactly what happens with Stereolab. If you instead use the FFT curve fitting filters, once again the sin x over x goes in, encoded into RAAA, but that's what comes out. So the frequency is compensated, but the phase is not corrected. Only Stereolab has the software implementation of real analog filter structures. The transfer function of the filters is the conjugate of the hardware filters in the cutting lathe. And we checked that too, so we researched the encoding filters in real record lathes to check that our filters were true conjugates.